Laplace transform of cosine integral function. Yeah. So in this video we will basically see how to take the Laplace transform. Yeah. The way we will do it is one of the way that's possible is to just to convert this to an integral, integral definition, and then change the integrals and find the Laplace transform and then again integrate. So let's see how we do it. We know that the cosine integral function is defined as negative of the integral from x to infinity of cos t by t dt. Yes, so now this is integral from 0 to infinity e to the power minus alpha x. Then ci of x is integral from 1 to not 1, from x to infinity of cos t by t dt. Yeah, dt and then dx. Yes, now if y is t by x, this is done so that to convert the limits into numbers. Just that is the purpose of doing this. Integral from 0 to infinity e to the power minus alpha e to the power minus alpha x. Now this is integral from 1 to infinity. T is xy, so cos of xy by t is xy, and dt is x dy, and then dx. Now x cancels that out. Yeah, and since this is in the world of y, and this term is just constant, it comes inside the integral. Then we can interchange the order of integrals. 1 to infinity, 0 to infinity. 0 will also be dx dy, not dy dx now. And this is e to the power minus alpha x cos of xy by y, and then dx dy. Yeah. Now in the world of x, now y is constant, take the constant outside. 1 to infinity, 1 by y. Now we have e to the power minus alpha x cos of xy, and integral from 0 to infinity. Now this is just Laplace transform. Now the Laplace transform formula, Laplace transform of e to the power of cos of at. This is just basically to the world of x is just basically integral from 0 to infinity of e to the power minus st cos of at dt, cos of at dt. Yeah. Now this is just basically s by a square plus x square. Yeah, that is the formula of Laplace transform. This can be derived easily using its Euler formula representation. Yeah. Now this one over here becomes alpha by alpha square plus x square. Yes. Is that good? Okay, it's good. And now wait. Over here we are dealing with x, y is constant. Yeah, so basically a was here the constant, so here's y is the constant. Sorry, I made that mistake. Plus y square. Yeah, now it's good. Yeah, now it's good. So sorry for that disruption. Yeah, something had happened in my home. Okay, now I can take the alpha outside. Integral from 1 to infinity. I have 1 by y times alpha square plus y square. Now clearly we can use the partial fractions now. Yeah, so I think we all know how to use the partial fractions. Yes, the partial fraction is to break this expression into two expressions. 1 by y alpha square plus y square to a by y plus by plus c by alpha square plus y square. Yeah. Now for this, we know that if we take the LCM over here, we get 1 is equals to a times alpha square plus y square. Yeah. And by plus c times y. Now if you compare the coefficients of corresponding terms, we know that here the coefficients of x y square will just be a, plus from here we have b as well. Yeah, now coefficient of y will just be c only, and the constant terms will be a alpha square. Yeah, now comparing the coefficients, we can say that a plus b should be 0 since there is no coefficient of y square, and then c should also be 0 since there is no coefficients of y as well, and a times alpha square should actually be 1 because the constant term is 1 over here. That implies a is just 1 by alpha square. Now if a is 1 by alpha square and a plus b is 0, it's clearly obvious that b is minus 1 by alpha square, and c, as you all know, it's 0. Now let's use the partial fractions that we have got. So we have got that this integral over here can be changed to a is 1 by alpha square by y plus b is minus 1 by alpha square times y, c is just 0, doesn't matter, by alpha square plus y square dy. Yes, and now let's integrate. Now it's the perfect time for using the high school integration techniques. 1 by alpha square, integral of 1 by y is just ln of y, and then plus over here it's minus 1 by alpha square. Yeah, now let's also take 1 by 2 in denominator so that we have 2y over here. Here it's y square plus alpha square. Now derivative of alpha square plus y square is just 2y, so that's why the integral will basically be ln of alpha square plus y square. Yes, now this goes from 1 to infinity. Now let us take alpha times 1 by 2 alpha square common. There's a reason for doing this, because if I do this over here, it will just be 2 ln of y, that is ln of y square, minus over here it will be ln of alpha square plus y square. It goes from 1 to infinity. Yes, now using the property of logarithms, you can say that the difference of logarithms is the logarithm of the quotient. Yeah, that's why we have 1 by 2 alpha. Over here it's ln of y square by alpha square plus y square, and this goes from 1 to infinity. So we are finally at the closing of the solution. Now we have 1 by 2 alpha. At infinity, both of them will be equal, so ln of 1 is 0, minus at 1, this is ln of 1 by alpha square plus 1. Yes, so now to reciprocate the ln, we need to take out negative sign, and if we take that out, we just have 1 by 2 alpha ln of alpha square plus 1. And this should probably be the answer. Let's check if it is answer or not. 1 by 2 alpha ln of alpha square plus 1. There seems like a minus sign has been mistaken somewhere. Yes, it seems like that, but let us see where. Okay, the minus sign is basically missed out in the definition of the cosine integral itself. Here in the definition we have minus sign. I missed that out, and the error carried over to all the solution. So the only thing that we need to do is put a minus sign, 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 and yeah, go on. Put a minus sign, put a minus sign, put a minus sign, put a minus sign, and that should be the answer. Minus 1 by 2 alpha ln of alpha square plus 1. Minus 1 by 2 alpha ln of alpha square plus 1. Yeah, so that is the answer. Hope you enjoyed the video, and the flow was just to use the integral definition and the interchange, use Laplace transform, use partial fraction, and then again integrate and find the limits. So that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.